Greetings was asked to do a couple of examples on confidence intervals for proportions and how to get the sample size requested for a particular level of the margin of error. So to demonstrate this, I decided to take a look at 6.19 from our textbook. So we'll do both parts, A and B here. Part A, they ask us to calculate a 95% confidence interval for the proportion of students at the university who smoke and interpret the result in context, reminder, check the conditions. So what they've got here are college students at a university, and out of a sample of 200 of the university students, 40 of those smoked. So let's start writing down all the information that we've got here. So first of all, we know that our sample size n was equal to 200 in this initial problem, and out of those 200 we got a success of 40. In other words, we got 40 of them that came up as they were smokers. Remember that the proportion is based on the binomial distribution, and so the things they're asking about in checking your conditions is we need to make sure that we're not sampling too big of the population, that it's less than 10% of the total population, which I'm assuming 200 students is less unless it's a really small university, and that those trials would be independent of each other. So in other words, that knowing that the one student that I selected smoked doesn't tell me anything about the rest of them. Those are the two basic things we need to take a look at. So I'll let you think about that some more. Okay, so what else do we need to know? Well, they gave us a confidence level in this part A. They said confidence is equal to 0.95. So if confidence level is equal to 0.95, let's quickly review how we get the corresponding values of z star. So if we had the standard normal distribution n of 0 by 1, and we want a 95% confidence level, then that means that 0.95 is here in the middle of our distribution, and we're going to have a lower and an upper value of z star. You'll have a negative z star down here, and you're going to have an upper value of z star up here. And such that, so that when we finish that, let's go ahead and get some color going here, so that the shaded areas in the tails are going to end up being 2.5%. In other words, this area right here is 2.5%, and this area right here is 2.5%. So that the total between the two of those comes to 5%, which gives us 100% for everything. Okay, so to calculate the values of z star, we're going to use the qnorm command. And qnorm requires us to put in as its first element the area starting from the left in the distribution. So we know that the area in this tail right here is 0.025, and likewise the area up here is 0.025. So if I put in qnorm 0.025, comma 0, comma 1, what I'm going to get is I'm going to get this one right here. I'm going to get the lower value of z star. So let's go over into RStudio and let's go ahead and do that. Get in the right spot here. Here we go. So let's put in qnorm. So qnorm 0.025, comma 0, comma 1, and I'll be honest with you, if you didn't put the 0 and 1 in there, it would assume you meant a standard normal. And we get negative 1.959964, which if we round that off to 3 places is negative 1.960. So get rid of the drawing here. So this is the lower z star would be negative 1.960. Well, we could just use the symmetry argument to get the upper one, because we know this is a symmetric distribution about 0, and this is 1.960 up here. Or if you were, just an uber geek and you wanted to get the upper z star here, you could go qnorm, do this just to satisfy your curiosity, and realize that the area below the upper z star is 0.975. So I put in 0.975, comma 0, comma 1, and you're going to get back the positive z star value. Okay, enough geeking on that. Let's go ahead and get our confidence interval built. So we need to build a confidence interval. We're going to need to know what p hat is, plus or minus the z star value, times our estimated standard error, which is going to be given by p hat times 1 minus p hat, divided by our sample size n. Okay, so let's go ahead and put in all those numbers. So first of all, I'm going to go calculate p hat here. P hat is equal to x over n, which is equal to 40 over 200, which turns out to be 0.2. So our estimated proportion of smokers is 20%. So what we want to do is build a 95% confidence interval about that point estimate. So 0.2 plus or minus our z star, which is 1.960, we'll just go 1.96, times the square root of p hat, which is 0.2, times 1 minus p hat, which hopefully you see that as being 0.8. I'll do some arithmetic in my head whenever possible. All of that divided by our sample size, which is 200. So let's go ahead and get the upper and lower tail regions of our confidence interval. I'm going to use RStudio to help me out with that. So I typically like to store them and then make it look like a confidence interval, but you don't have to do that if you don't want to. So let's see, I got to go 0.2, that is my point estimate. This is my lower one, so minus my z star, which was 1.96, times the SQRT of 0.2 times 0.8 divided by 200. Don't forget your multiplication symbols. You can't just set things next to each other and have that work in R. So we've got that's for our L, so hit the up arrow and we will get our lower one. Excuse me, our upper one. We're not going to get our upper one, we just got our lower one. And come in here, change that L to a U for upper value, and then go C of L comma U just to get it to bark it back out to the window, and there we go. So it looks like our confidence interval runs from 14.5% to 25.5%. Okay, so in other words, our lower level is 14.5% and our upper level is 25.5%. So this confidence interval is 14.5%. You should always report your answers back at the end as percentages because you want your mom to understand. If you gave it to her as a decimal, she probably would go, "What are you talking about, boy?" Anyway, enough of that. So now what? Well, what should we do with these? Okay, well, we got to interpret this. So with 95% confidence, remember we have a very specific definition of what confidence is. That's the probability that our system of creating an interval to capture the population parameter worked. So we're 95% confident that our system worked. So with 95% confidence, the proportion of students that smoke, of smoking students, I want to say smokers, I'll just make it easier here, is between 14.5% and 25.5%. Okay, cool. All right, so that takes care of part A. Hopefully that all makes sense to you. So let's go ahead and get rid of all of this. Get this out of our way. And let's go take a look at part B. Okay, so in part B, we're going to go do a sample size calculation. So we want to know in part B, they're looking for a particular margin of error. How many folks should we sample in order to be able to get that? So we want our margin of error to be no larger than 2% at a 95% confidence level. How big should our sample be? So quick reminder again, just from we're doing a confidence interval, our margin of error is going to be given by z star times the square root of p hat times 1 minus p hat all over n. That's how you calculate the margin of error. So what we want is we want that to be less than or equal to 0.02 or 2%. So let's go ahead and plug in everything we know. We know what our z star was. That's 1.96 because we did not change our confidence level. We know what our p hat is. Our p hat was 0.2 and our 1 minus p hat was 0.8. The only thing we really don't know here is n. That's what we're looking for. So we want that to be less than or equal to 0.02. All right, so now you have to use this thing called algebra. And you need to solve this thing for n. So our first move is to get that 1.96 out of here by dividing both sides by 1.96. Good old algebra. Thought it went away, but it didn't, right? Okay, so once we got that done, now we end up having the square root of 0.2 times 0.8 over n is less than or equal to 0.02 divided by 1.96. And what I need to do now is I need to get rid of that square, that square root. And so to do that, I'm going to wrap both sides in parentheses, and I'm going to square both sides. And when I do that, the square root and the square are inverse operations to each other, and it'll get rid of that. So if I go ahead and remove the square root for both sides, I end up with 0.2 times 0.8 is less than or equal to, that's still divided by n, is less than or equal to, parentheses, 0.02 over 1.96 quantity squared. All right, last but not least, let's clear the fraction by multiplying both sides by n. So I've multiplied this side by n. It's actually not last, we have one more step after this. And multiply that side by n. What we see is that these n's will cancel, and we end up with 0.2 times 0.8 is less than or equal to this crazy number times n. So our next move is going to be to divide both sides by the crazy number. In other words, take 0.2 times 0.8, and let's divide that by 0.02 over 1.96 quantity squared, and that'll be less than or equal to n. All right, cool. Now we're ready to get to your calculator, or as I prefer to go to, just to go into RStudio, because it's a great little calculator, and we need to do this calculation. So let's go back over here, give ourselves a clean console, and let's see, in the numerator we need 0.2 times 0.8, and then divide that by parentheses 0.02. Remember, that's our desired margin of error, divided by 1.96, that was our z star, and that whole denominator has got to be squared. Squared, not the ampersand there, okay? So it looks like we need about 1,537 participants to keep our margin of error less than or equal to 2%. No matter what you get over here, you're always going to bump it up by at least one, okay? Now, to be honest with you, in the real world, they would probably say, oh, we need to get at least 1,700. Why? Well, because many times you take samples, and in the process of samples, you have an unfit sample for whatever reason, and you have to throw a piece of data away. And if you need to keep that 2% margin of error, that's the lower end of what you're going to need in order to keep that 2%. So many times we'll sample slightly more than that number to keep our margin of error where we want it. Okay, well, hopefully that helped, and that everything is feeling so much more happy and comfy. And I will hopefully be back here with a video in a bit about how to do chi-square.